I'm going to talk about better web application development. I'm Sean Kelly. First, some history. In the 1990s, I was in Boulder, Colorado, working for NOAA, specifically the National Weather Service, on the next generation workstation for use by weather forecasters. See, back then, satellite images had to be viewed on one kind of equipment. Radar images were viewed on a different piece of equipment. The output from computer model runs were viewed on yet another piece of equipment. In fact, there was a different piece of hardware for virtually every different kind of product that a weather forecaster would want to use. We wanted to unify all that. By putting all of that data onto the same screen with the same map background, we would be able to produce better forecasts, and it would also be cheaper because there'd be less equipment to maintain. The system was called AWIPS, the Advanced Weather Interactive Processing System. It's a typical government acronym, not very good. We had a variety of tools at our disposal to develop AWIPS. For data collection, we use C++. For conversion, because we had all this data, it had to be scaled to various map backgrounds, we use C++. For archiving and aging of that data, we use C++. For generating warnings for the public, we use C++. For geographic information, like county boundaries and road maps, C++. And the user interface was also C++. The user interface sucked. Any change to the interface required us to recompile it. And this was C++ with templates, and so compilation is slow. Any change from small to large had to go through a recompile cycle. So we tried to plan as much as possible. But no matter how much we plan, that really is just a small part of the user interface battle. Most of the changes that you'll make to your user interface, most of the improvements you'll make, come from users actually playing with the user interface and telling you what they think. Recompilation took way too long, so we didn't do it, and as a result, the user interface sucked. Until one day, I just could not take it anymore. I looked at our tools and realized that we were using the wrong tool for the user interface. I replaced it with a scripting language. I used TickleTK. This gave us rapid turnaround. We could respond rapidly to users' changing demands for the user interface. In fact, I could often make changes right in front of the user, get feedback. For example, a user might say, oh, I like the way that worked, or, you know, it was better the first way, let's put it back. The user interface stopped sucking. This is what it looks like, and in fact, it's installed at every single forecast office in the United States, as well as Guam and Puerto Rico. Conclusion is that compiled languages work fine for the back end. They were awful for the user interface. To have a successful user interface, you've got to have rapid turnaround. Now, let's move to the present. In the 2000s, I found myself in Pasadena, California, working for the Jet Propulsion Laboratory. Application development in this day is very different from what it was in the 90s. It uses technologies such as HTTP and web browsers. The user interfaces for these applications are different as well. They're less about widgets and more about page layout. But they're still user interfaces. They're still places where humans and computers must come together and work to get a job done. Now, we are a Java shop. When it comes to the Enterprise Edition, we's in love. For the data collection, give us J2EE. For conversion of data, we love J2EE. Archive and aging, pass me the J2EE. Optimizing queries, oh, we're all over J2EE. For metadata management, we use J2EE. And for user interface, we use J2EE. The question is, should we? Is J2EE good for web app development? Or is it too slow? Remember, rapid turnaround is absolutely vital. And what about ObjectSpace? I'm ready to start implementing it. And ObjectSpace is all about HTTP. All of its interfaces, WebDAV, SOAP, XMLRPC, REST, are HTTP, and so is the user interface. Should ObjectSpace be implemented with J2EE? Well, let's find out. Let's put it to the test. We'll let J2EE square off against a variety of frameworks that all follow the same general model. We have a web browser which communicates with an HTTP server. It communicates with some business logic, which communicates with some persistence layer, usually a relational database. You might recognize this as the N-tier architecture, where N is always 3. I'm not sure why they don't just call it the 3-tier architecture. The contenders will be Ruby on Rails, Zope, specifically Plone, TurboGears, Django against a partial J2EE system using servlets and Hibernate, and a full J2EE system, in this case, JBoss. The metrics that we'll use to determine success will be, first, fast. If there's no rapid turnaround, it's a no-go. Throw the framework out. Next, it's got to be easy. If it's easy to use, that means it has ideas like convention over configuration. Web applications all follow the same convention. Any other configuration which lets you work outside of those conventions is a waste of time. It should also eliminate XML sit-ups. A lot of time that configuration takes the form of XML configuration files, which in the end don't buy you much. I call those what the Ruby on Rails people call those, sit-ups, an annoying exercise in futility. There should be no SQL. Machines can generate SQL a lot more reliably and efficiently than humans can. I make errors generating MySQL statements all the time, and I don't need to do it anymore because programs out there can do it for me much better. It should be also easy to install, have good documentation and support. The framework should also be secure. That is, it should validate any data presented by the browser and provide password authentication and role-based authorization. Encryption, I'm going to assume, comes with the system by using HTTPS. It should also support integration. Integration at the persistence level means integrating with legacy data systems. Integration at the logic level means working with external toolkits. I'm going to assume that at the persistence and logic levels, that every framework being programmed in software of some kind can interface with legacy data and external toolkits. The real integration I'm concerned about is at the user interface level. Can it generate page templates that work with HTML editors? Also at the user interface level is the international level. A lot of times if a project is successful, people from around the world will want to localize it for their own languages. This won't be a deal breaker for frameworks, but it will give a framework extra credit. Finally, it's got to be fun. And why? Come on, fun don't need a reason. Let's get started. Test number 1 will be to write a Hello World application. Why Hello World? Well, just to get a feel for what the different frameworks are like. First up will be J2EE using just servlets. We'll do this screencast style because, hey, screencasts are cool. All right, so let me clean up my desktop here first. And I'll make a directory to hold my application. I'll need a source directory for the web app and for the Java source code. Start up my favorite editor, and first thing we'll do is the servlet. We'll put the package declaration in there. We'll import the servlet request, servlet response classes, exception, IO exception, and then make our hello world servlet. It extends HTTP servlet. The doGet will take a request response, can throw a servlet exception or IO exception, and we'll just call print line on the request writer to print out the HTML. Now, the web XML, the deployment descriptor, will have a doc type declaration to be anal retentive, and the web app declares a servlet named Hello World and its class called Hello World, and the mapping for the Hello World servlet will be /hello. We'll save our web app. Now we'll make the Maven project descriptor. The ID of this project is Hello World, called Hello World, current version 0.0.0, produced by ODT. Source directory is in source Java, and we do have one dependency on the servlet API, of course. We'll be using version 2.3 of that API. We'll make a maven.xml file, which says that our default target will be the war. We always want to build the war file. Okay, so let's call Maven and see if we got any compilation errors. No problem. All right. We now have a war file in our target directory, so we'll copy that to our Tomcat web apps directory and start Tomcat. Bring up our browser, and let's see what we get. Okay, 404. Let's check our catalina.out file. No error messages in there, but if we go right to Hello World, we get a directory listing, so it did find the web app. Ah, look at that. The directory is called web apps when it's supposed to be singular, web app. All right, so let's rename it and rebuild it. And let's copy, or actually remove all the old Hello World war file, copy the new war file in there, restart, and we still get a 404. Okay, catalina.out. Oh, look at this. Our doc type declaration that we put in to be anal retentive has got a problem. We didn't put in the name of the root element or the word public. So let's add those, rebuild, and erase the old one, copy in the new one, restart Tomcat. Wow, it worked. That wasn't too bad, I think. That was 55 lines of code, 3 XML configuration files, and multiple restarts of our server. That's what I call a pain in the ass. The fun score for this, I can't imagine it being anything above 0. Could we have made this more fun by editing the context in the server.xml file for Tomcat, specifically setting reloadable equal to true? No. Why? Well, what we did is we misspelled the web apps directory, so Tomcat treated that as just another document subdirectory of the web application. This essentially was a compile time error that we found at runtime. Secondly, we had an error in the web.xml file, and that isn't rescanned when you set reloadable equal to true. Not to mention that editing that file would have been a 4th XML setup. So no, not fun. Let's try using a JSP this time. Okay, so what we'll do is we'll go back to the web.xml file. We can get rid of all the servlet declarations. We'll make an index.jsp file, put in the JSP page declaration, and then we can just do some HTML. Hello world, body, h1, hello from JSP, close the body, close the HTML. We can then rebuild our web application with Maven. For some reason, I'm doing it a second and third time here. Remove the old web app, copy the new one in, and restart Tomcat. And now if we go to Hello World and delete the hello, because we called it index.jsp, sure enough, we get hello from JSP. That was 34 lines of code, 3 XML configuration files, and 1 restart. Fun factor, barely 0.1. How about Rails? Rails is based on the Ruby programming language, which is a elegant and very easy to learn programming language indeed. I like it a lot. With Rails, what we'll do is we'll make a controller, which is the equivalent of a servlet. Let's see how that looks. Okay, we'll make a directory for our Ruby experiments. We'll call Rails Hello World to make a new Hello World project and create a Hello controller. We'll start up the server called the WebBrick, and then we'll open up our controllers, and here's our Hello controller. We'll define an index method which calls render text, and the text will just be the HTML that prints hello from Ruby, done as a here document. And save that, go to our browser, and wow, it works, hello from Ruby. That was 16 lines of code and no configuration files. Fun factor? Actually, it was kind of nice. I'll call it a 0.8. Now let's try it again, but with a view, what would be the equivalent of a JSP. Alright, so we'll go back to our controller. We'll get rid of that render text and just leave an index. Then we'll go to the views directory and make an index.rhtml file, Ruby HTML, and just put in HTML, title, body, h1, hello from a Ruby view, close it, save it, reload it, and wow, it worked. That was 15 lines of code, still no configuration, and still no restarting, and still fun. Now let's try Zope. Zope is based on Python, which is popular with the folks at Google. For Zope, we'll create a Python script, the equivalent of a servlet. So here's my terminal. I'll call make Zope instance, create a brand new Zope called myZope, and a user admin with a very secret password. Then I'll run Zope, go to the management interface, and log in. From the add menu, I'll choose to add a script, call it hello, and it gives me a screen with a sample script that puts in some sample text. Let me get rid of all that and instead output my HTML hello world. Head, body, close it, save, and then go up here to test, and I see it works. And in fact, if I put in just the URL hello, which is what I call the script, it works just fine. So pretty easy, actually. That was 9 lines of code, 0 configuration. Heck, I didn't even need to start up my text editor. The fun factor? Oh man, that was fun. And security came for free. Now let's try again, but this time using a Zope page template, the equivalent of a JSP. Okay, so Again, I'll come to the Zope Management interface, choose Page Template. This one I'll call Hello PT, and I see it comes with a page template already. Place for some metadata up here called a title, so I'll fill in that title. Let me get rid of the HTML they had here and insert some of my own and call it H1 Hello from a Zope page template, press save and test, and that works. And indeed, I can even go back and add an expression here which says replace the content of this H1 with the template title, change the template title, press save, and sure enough, I even get variable substitution. Wow, what could be easier than that? That was 8 lines of code, and again, 0 configuration. Variable replacement came for free. Definitely a lot of fun and extremely productive. But there's still more frameworks to try out. Let's try TurboGears next. TurboGears is a web application framework, again, based on the Python language. We'll start by making a TurboGears controller, the equivalent of a servlet. Alright, so make a directory to play with TurboGears, and I'll call tgadmin quick start and make a Hello World project. Then I'll start the Hello World server, and now it's going on port 8080. Let's go to the TurboGears Hello World directory, open up my controllers, and let's get rid of the default HTML page it generates, goes to the welcome page, and instead return our own HTML document, title Hello World, head, body, H1 Hello from TurboGears, close it, save it, and then we'll go to our browser, and wow, look at that, it worked. Hello from TurboGears. That was 14 lines of code and absolutely no configuration. Of course, you don't always make web pages from servlets, you make them from JSPs, or at least in TurboGears, a page template, a view. So let's see how that works. What we'll do is we'll go back to our index and say just return an empty dictionary, but the expose statement will take a HTML equal templates hello, and then we'll just create this file called hello.kid, which will contain our HTML. Save that. We don't even have to restart the server. Now when we go to the browser, we get hello from a TurboGears template. 20 lines of code, no configuration. Definitely fun. One more framework, Django. Django, named for Django Reinhardt, the Belgian guitarist. I don't know who he is, but oh well. It's yet another Python-based framework. Python seems pretty popular with web applications. Maybe that's why the folks at Google use it. For Django, we'll create a Django controller, again, the equivalent of a servlet. So that works like this. We'll call Django admin start project myDjango to create a new myDjango workspace. And in that directory, let's use our editor to find the configuration. Now we have to set up the database. Even if we're just generating static text from a static servlet, Django requires your database. So I'll call init. That will contact the database and set up some basic tables. I'll call start app hello to create a new application within this project called hello, and then create a super user called root, and then I'll start the server. The server is now running. Next, I need to edit this URL configuration file. This will tell Django if a URL comes in for hello, what controller it needs to go to. And then we'll create a method called index, which will return an HTTP response constructed with a string, and the string is the HTML which says hello for Django. I need to import the HTTP response class, save that. Now let me go to the browser and, oh god, what port was that again? Oh yes, 8000, not 8080. Page not found. Let's see, it didn't like that. Oh right, I forgot. Add hello to that, and I get hello from Django. Alright, so we had a few fits and starts there, but 11 lines of code, 2 configuration files, non-optional database. Not optimal, it worked. That regex-based URLs, that's a little annoying. Security was built in, at least authentication. We haven't seen the rest of it in play yet. Let's try now a Django page template, the equivalent of a JSP. So to do that, I'll go back to my views. Let me blow away everything we have here. I need to edit the settings file again and tell it what directory it can find templates in. So I'm going to call that my templates. I'll then change the URL so it goes to a hello template. Go back to the views file. I'm going to import something called loader to load the template, context, which holds variables for the template, and I need the HTTP response again. So I'll say template equals loader get template, hello/hello template, context is empty, and then return that page template. Then I can create the hello template, which is an HTML file, says hello from a Django template, save that, and if I go visit it, I get a template does not exist. Okay, let's see why. Hello template looks fine. Oh, look at that. I had a directory hello/hello template when it was just hello template without a subdirectory. Now it works. 15 lines of code, again, 2 configuration files. Let's see the score so far. Okay, Java 2 Enterprise Edition, score, sucks. Ruby on Rails, rocks. Zope, or Plone, rocks. TurboGears, rocks. And Django, rocks. Hate to say this, but J2EE is not doing too well. But that was just the first test. Test number 2 will put these frameworks through a far more realistic development approach. We'll be making a time tracker. The goal, build a time tracking web application. The data model will look like this. This UML diagram shows that we have a time log, which has a name. It can contain 0 or more time entries, which have an activity name, a start date, and the total minutes, the duration spent on the activity. So you could have a separate time log for PDS work and one for EDRN work, and then within each one of those, you can track the activities that you perform. So here we go. We'll start with a partial J2EE solution using JSP servlets, Hibernate, and a MySQL database. I'm not going to screencast these because this presentation is already getting long. First step is to write the Hibernate object relational mapping XML files. Then you write servlets, write some JSPs, and repeat until you're done. So this is what the time tracker looks like. Here I've got one time log with a couple activities and space to enter a new activity. Here's the tally so far. That's 6 Java source files, 2 JSPs, 6 XML configuration files, about 500 lines of code. While developing this, I had 6 compile time errors, 12 runtime errors, and 2 headaches. Now, what exactly is a headache? It's that level of frustration you get to when an error message is just not explicit enough, when something is just not helpful, when something mysterious goes on, or when you just get frustrated and you want to rip your hair out and rip out the whole framework. This happened twice while developing this particular application. Total time on this, 225 minutes. And it doesn't support editing. This is an add-only interface. You can add time logs and you can add time entries to them, but you can't modify them once they're added. There are way too many XML setups, and there's as many XML files as there were source code, plus more lines of XML than there were lines of source. Now, we are Java developers, so we love XML. But paraphrasing a famous American psychologist, when all you have is XML, every problem starts to look like markup. That's not necessarily a good thing. For more information, there's an article at developer.com written by yours truly called Making Mistakes with XML. Go take a look. There is also no security in this application. Anyone can add anything at any time. There's no validation of the input, making this ripe for injection and cross-site attacks. There's poor HTML editor integration because JSPs use their own special tags, which don't work in applications like these. Now, these are the applications that web designers use. Now, why would you use a web designer? Well, remember, web applications in the 2000s are less about widgets and more about page layout, and web designers know how to lay out pages. Plus, even if you don't have a web designer, being able to preview your forms in a browser is a good thing, but you can't do that with JSPs. Also, this interface is English only, but on the plus side, there's not a single line of SQL in the entire application, and that's kind of nice. The documentation for J2EE are excellent. Numerous books, online resources, mailing lists, chat rooms. But given about 500 lines of code and over 200 minutes to develop, it doesn't seem very good. Let's go on to Rails. In Rails, the first thing you need to do is manually make your MySQL tables. Then you can auto-generate controllers based on what Rails finds in your tables. And you can also auto-generate views from those. You do need to hand make some views. The view generation isn't that sophisticated. This is what it looks like. As you can see here, I'm creating a new time entry. Rails even went so far as to figure out that my start time was a date time field in the database, so it gave me a bunch of pull downs instead of a plain text field, which is what I use for the JSP solution. If you want more polish, you can hand make every view. The nice thing about this is that Rails generated both the add and edit pages as well as the view pages. So, the tally. 2 Ruby source files totaling just 6 lines of code, 1 view which was 23 lines. Total really not bad, about 30 lines of code altogether. There was only 1 runtime error and 1 headache. And the headache that I had in developing this was that I originally called my log class just log instead of time log. The error diagnostic that Rails produced was completely unfathomable. I did get help, though, from an IRC chat room devoted to Rails. Someone suspected a name conflict with the name log, and sure enough, just renaming it fixed the problem. Total time, including that chat, 13 minutes. That is an astounding improvement over the J2EE solution. There is one configuration file, it's not XML, that you do need to edit for Rails, where you tell the database name, user, and password. And you do have to write SQL by hand at the beginning when you define what your tables look like. And I think that is unfortunate. I hate writing SQL. But at least I didn't have to write any queries. I just had to write the data definitions. When you're defining those SQL tables, you also have to follow special Rails rules, rules in naming and types. For example, tables need to have an ID column, and it has to be all lowercase, and it has to be the first column of the table, and it has to be auto-generate, non-null, primary key, etc. This means that integrating with a legacy system by just bringing in the database, that's not going to work. Instead, you'll need to develop code to interface to that layer. Not unless you can change the database fields. Rails also doesn't provide security. It does do validation of input from the browser, but you have to roll your own auth and auth. Also, tags in Rails look like this. So, it does not integrate with HTML editors, and you can't preview pages that you make cleanly in a browser. You also have to roll your own internationalization. It does have great docs, plenty of books, and online resources, including a very responsive chat room. It was a lot more fun than J2EE, though. Now let's look at Zope with Plone installed. With Zope, the first thing you do is you make a UML model to describe the data that you want to track. And in fact, we already have one. So all I have to do is take this model and add tagged values. The tagged values tell Plone and Zope what widget labels to use and help text for them and various on-screen icons that you'd like and any extra validation you want performed. This is what it looks like in Plone in Zope. As you can see, it actually looks great. It's a very attractive interface, and it's also completely skinnable, meaning that you can modify the interface to have lots of different appearances for different users, and all without regenerating any page template code. Internationalization is built in, should we need to translate this. Also, it required 0 configuration. It came with its own object database. It's not using some old-fashioned relational database with SQL access. Instead, we're using a modern object database, which has automatic Lucene-style full-text indexing, so our time log and time activities are full-text search enabled by default. It's also secure with automatic validation of input parameters, built-in user authentication, and role-based authorization. There's also just an incredible amount of metadata associated with every object we create, like our time logs and time entries. Every object has the full set of double and core, and an object history, so you can go back and view older versions of them. There's built-in WebDAV, XML-RPC, and SOAP is forthcoming. Let's look at some numbers. Wow, look at that. I didn't have to write a single line of code for this, and the Zope page templates were automatically generated and completely customizable because they're pure HTML, and so they integrate good with editors, and you can use a browser to preview what your pages will look like. There was no code, so there were no errors, and certainly there were no headaches. Docs are actually great for Zope and Plone. There are multiple books on Zope, multiple books on Plone, and there's a Plone chat room which is extremely responsive, as great as the Ruby on Rails one. I consider that lots of fun. And in fact, it took 7 minutes to do. This is a huge win. But we're not done. We still need to look at TurboGears. So for TurboGears, you write your model in Python, which then auto-generates your MySQL table. So we're back to relational technology. At least you don't have to write SQL. You then write controllers, and then you write page templates to display and interact with your data. Here's what it looks like with TurboGears. TurboGears included that logo automatically. You can remove it. I was lazy. It looks a lot like the JSP page. TurboGears doesn't automatically generate pages for you, which is the main reason why. So this is another add-only interface, no editing. To make page templates, you write .kid files, which is the TurboGears template language. It is pure HTML, though, which is a good thing. That means it'll integrate with editors, and you can preview your forms in a browser. So, numbers. 2 Python source files you had to write, 49 lines of code. 2 page templates, 53 lines of code. About 100 lines of code. I had 14 runtime errors getting this thing working. But that's really not a problem. With TurboGears, you use a very interactive development style. In fact, you use the errors to sort of direct what part you go to next. You first write a welcome template. You view it. There's an error in trying to get data out of the database. So you define your models, and then you view those. Then you add a link to add a new entity. That gets you an error, so then you write the add entity form, and so forth and so on. So I don't call them failure runtime errors. They're more on the appraisal side of things. So let's rewrite those numbers to 000. Total time to develop this one, 59 minutes. Why? Mostly, again, it doesn't auto-generate anything for you. You have to hand make every page. Input validation is supported, but you have to roll your own auth and auth. You have to roll your own internationalization. The docs are okay for TurboGears. I haven't found any books on it yet. I'm sure some are forthcoming. Online resources, not too bad. Overall, though, it was pleasant. It was sort of fun to do this much more interactive kind of development. I'd rather skip it altogether where possible, of course. All right, now let's look at Django. For Django, you write your model, all in Python. It auto-generates your MySQL tables. So far, it's very similar to TurboGears. It has a built-in administrative interface which generates your add and edit forms, and it looks like this. So here I am adding a time entry. Actually has a very nice calendar widget as well too. It was so quick and so easy, and it made of an attractive interface. You can, of course, develop your own views using a Django-specific template language, which looks something like this. And of course, as you can see, because it looks like that, it won't integrate with HTML editors, and you can't use clean browser previews. So in the end, I had to just write 1 Python source file, 19 lines of code. Everything else was generated from that model code in Python. The regular expression-based URLs that we saw earlier actually aren't even needed this time because we're using a data model and Django figured out the rest. They are still available, though, and you can do some pretty sophisticated stuff with them. Of course, you can also injure yourself with them. There were no errors or headaches in developing this Django-based application. I didn't have to write a single line of SQL. Security did come with validation, authorization, and authentication. The docs for Django are, they're sort of in the TurboGears state. They're okay. Books, nah. Online resources, yeah, we'll see. You have to roll your own internationalization, but that pretty much is one of the only blemishes. Overall, that's fun, definitely. Finally, JBoss, the full J2EE solution. Let's make the time tracker with JBoss. What is a full J2EE? Well, we've been using serverless and JSPs a lot. That's just part of what J2EE is. Full J2EE adds various other technologies and enterprise Java beans. Unfortunately, enterprise Java beans suck. They're very different from the regular bean model. They have poor event support. It support a new query language. There's no read-only views. There's no validation. They have complex interfaces. You have to write a home interface and a remote interface, and it's not clear when both are sometimes needed and some are otherwise not needed. You have to have even more handmade scaffolding, and the roles between entity beans and session beans isn't entirely clear. There's even more XML setups, and the very fragile configuration with poor diagnostics makes turnaround even slower. So, EJBs suck. For more, Just do a Google for EJB's 101 Damnations, and you'll find a very well-written article which criticizes EJBs. Or just Google for EJB sucks. So, the JBoss time tracker is over budget, late, buggy, and has been scrapped. Conclusion. Rapid turnaround is absolutely, unquestionably, irrevocably vital. J2EE does not support rapid turnaround. J2EE is not appropriate for web applications. What is then? And do you have to learn a new language? Well, second question first. Yes, you do have to learn a new language. But come on, you work for JPL. You'll probably learn a couple of new languages over the course of a weekend, no problem. And so what's the answer? Is it going to be Rails, Zope, TurboGears, Django? Well, here's the raw data. I'll let you decide. Thanks for listening.